Good morning, students. Slowly joining. Students are slowly joining. It's 18 now. Well, hope the screen is visible to you. Are the slides visible? See, in the last class, let's have a quick recap. Okay. In the last class, we had a basic introduction to the artificial intelligence. We have come across various definitions given by various famous authors. See, all these are the definitions, and we have broadly defined artificial intelligence in 4 dimensions. Could someone tell me those 4 dimensions? Thinking humanly, thinking rationally, acting humanly, acting rationally. And we have looked at 8 different definitions with respect to those 4 dimensions. Besides that, few more definitions we have come across. So, all these are the definitions that have been proposed by various famous authors, and any of these definitions can be taken into consideration. And then we had the history of AI, where it started its journey from 1956. It was initially coined by John McCarthy, and so most of us, or most of the world, call John McCarthy as the father of artificial intelligence. Then, as I said already, there were many ups and downs. Initially, that was promoted by the various societies in the government sectors. Later, there was a downfall due to the wrong mindset of the people over there. And then again, it had a boom, and now it is into its peak. Without AI, there is nothing. So that's a brief history of AI. And then we had a discussion on intelligent systems. Intelligent systems means it has, see, when I say intelligent, it should be mentally capable of making its own decisions, just as human beings do take decisions. That's how we should go ahead. So when we say this intelligence, we consider learning process, we consider reasoning process, inferencing process, perceiving, comprehending, everything that comes into picture, just like a human being. And I've also come across 3 types of artificial intelligences, namely weak, strong, and super. See, and the first, any intelligent system should pass this Turing test, and we had an introduction to the Turing test. This is how it takes place. When a human poses a question, there'll be two different types of responders. One is a human responder, the other one is the system responder, where the system responds. Now, the human will not be in a position to know whether system is responding or the human is responding. If the human cannot determine, if the human is uncertain about the responder, then we say that the Turing test has passed. And any intelligent system, if it passes the Turing test, then we call that as a good intelligent system. And one of we have looked at the first of its kind, ELIZA, an intelligent system. The discussion that took place here is a sample discussion between the system and the that is the for the Turing test. And then certain key characteristics of ELIZA intelligent system, that is the simulation, quality of response, coherence, semantics, all this. And then this categorization, which was initially discussed as 4 different dimensions. See, systems that think like humans, that means human thinking like human, thinking humanly, thinking rationally. That's the thing. So requires cognitive modeling approaches. Functioning of the brain should be known. That means where the neural networks concepts come into picture. So from this, what should you understand? Neural networks is relevant to artificial. That means that if artificial intelligence has to properly take place, there should be proper correlation with neural networks. Say the second one, systems just act like humans. This is thinking like humans. This is acting like humans. That means it should behave like a human being. That's what See your human android systems. Maybe in the movies you might have seen. See the systems behaving like human beings. Maybe Sophia you might have seen in the last 2 3 years back, where the Nara Lokesh was interacting with the human android system. That's Sophia. The systems that think rationally, where it depends on the logic than the humans. And next thing that act rationally again based on this, whether it is doing the right thing, whether the logic is correct or not, it does the right thing. So based on these four dimensions only, but based on these four categories, we have considered various different dimensions. This is where I stopped, if I remember. Is that okay? Let me see. I have 38 students. So here I'm going ahead. See, that's the quick recap of what happened in the last class. The different dimensions, the history of AI, and then the Turing test, and then the intelligence systems, and an example of intelligence systems, ELIJA. In continuation to the previous class, let's move ahead. Uh, how should we understand intelligence? See, when this is a very basic question. See, the intelligence could need not be uniform across everything. See, my intelligence would be different, and your students' intelligence would be different. It varies. See, that's what we normally measure IQ, intelligent quotient, we say, and it varies from person to person. So when we say intelligence, there will be several aspects that come into picture. See, these are some of the aspects of that. So you should think abstractly. You should be able to solve problems. Intelligence, see, intelligence includes all or some of these features, some of these characteristics. Reason and draw meaningful conclusions, plan sequences of actions to complete a goal, solve problems, comprehend ideas, store knowledge provided before and during interrogation. That's how, see, in the course we do, the judges take a decision based on what? Based on the discussion that take place, based on the proper reasoning that takes place, and accordingly based on the proofs that are the evidences that are available, they come to a conclusion. That's also a kind of intelligence. And learn new ideas from environment and new circumstances. Other advice, see, new environment, say from environment. Now that we are running in a typical phase, a very pathetic phase, that is the COVID around us. We are living with COVID. So accordingly, we are taking necessary measures. Accordingly, we are acting. See, see, all this comes into picture. See, offer advice based on rules and situations. That's learning based on rules. Learn new concepts and tasks that require high levels of intelligence. Where it should be obvious. So suppose if I say in a car driven driverless cars, driverless cars. When I say driverless cars, how should you do it? We should consider that as in, see, it should have the good intelligence where it should predict everything, what's going to happen and what kind of traffic is there and what's there in front of it, and accordingly it should be able to take a call. So that's what. So that's how. So when we say intelligence in general, this adds. See, these are some of the abilities that have been presented over here. Some of the characteristics. Do not go with the wrong impression that these are only the characteristics. So intelligence includes some or more than these also, or these only. That's how you have to go. So the components of AI program. Say, as we said, when we want to make the system to work properly, it should have certain key components. What are those key components? Normally, this knowledge base. When we say knowledge base, this is as good as the database. See why? When it is data, we call it as database, but when it is knowledge representation, we normally call it as hello, hello. Any doubts? Someone is unmuted.
No, sir, by mistake. No.
Okay, 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 okay. See, when we say knowledge base, see, when we say knowledge base, so you just map this to or take your quotes sequence as an analogy. See, based on the knowledge the process, the judge takes an intelligent decision. So now the system should also do that. See, when you play chess with the system online, how does, in most of the cases, the system wins? How? That means it has been programmed that way. It has been fed up with all the data is properly, that data is nothing but knowledge. See, if this is the sequence, what should be the next action? So all those different sequences are placed over there. So based on that, based on this input sequence, accordingly, it's going to map it to its existing database, that is knowledge database, and makes a decision. So obviously, the volume size of knowledge base would be huge. So when the volume size of the knowledge base is huge, it should be properly structured such that efficient action should take place, and it should keep on changing because it's a learning process. The new knowledge should be kept added, and the old outdated knowledge should be removed. And there should be proper control strategies. See how you should have a definite rules, specific rules. Which rule is to be applied? As I said, when I make this move on the chessboard, what should be the consequent action by the opponent? So that's what and the rule. Which rule is to be applied? Then the inference mechanism. So based on the situation, it should be deriving new knowledge from the existing knowledge and use that knowledge to the application. So these are some of the key components: knowledge base, control strategy, and inference mechanism. So these three components play a very critical role for writing down a program relevant to artificial intelligence. When you say, suppose if you are asked to write down a simple program and not using for any artificial intelligence application, three things are necessary. So you should have necessary data. That data is nothing but knowledge to make a decision. Normally, some call them as patterns. Doesn't matter what we call them as, it's nothing but knowledge representation only. And so you should be effectively representing the knowledge. How effectively you represent the knowledge, accordingly the actions take place. So the control strategy, and then you should be inferring new knowledge based on the existing knowledge. Okay, so inference rules will be developed. The foundations of AI, as I said, see, it's AI is not independent. AI depends on several other disciplines. So some of the disciplines it depends on mathematics, neuroscience, control theory, linguistics. You may wonder how are these relevant? Mathematics, yes, we make a decision. See, we use Boolean logic, we use predicate logic, we use predicate calculus in order to make out a decision. So it's an formal logical methods would be used. The When we want to measure uncertainty, we normally deal with the probability theory concepts. So all definitely AI needs the knowledge of the mathematical concept to properly handle the application on there. Then say this neuroscience, when you want to diagnose something, if you want to use the artificial intelligence in the medical field, definitely the neurological science, you should know what a neuron is, how does a neuron work. Suppose if an action is given, if an input is given, how does it react? So that human activity, the brain activity, should be taken into consideration. So that's how neuroscience is also. These are some of this. Do not go with the wrong. Say, as I'm saying, since I mentioned only four, these four, don't go with the wrong sense that oh, these are only four disciplines that contribute to artificial intelligence. These are some few. The control theory. See, the machines can modify their behavior in response to the environment. So, see, how does the ACs behave? See, when the room is totally cool, what happens? The A3 automatically turns off. And again, when it reaches the necessary temperature, again it turns on. So something like that, it should behave. So it should be able to modify its behavior based on the situation, based on the environmental conditions. See here, something like water flow regulator. So your electric cookers, something. It should your washing machines. So similarly, linguistics, which should be able to recognize speech, it should be able to convert from one language to another language, which you might have seen in Google Docs, where you enter text in one language and then you can convert that into other languages, including Telugu language that has been included over there. You can check it in Google Docs. So there are several disciplines that totally contribute to it. So AI depends on several disciplines uh, to succeed in its field. So if you want to become a very good AI programmer, you should have at least the fundamental knowledge on some of these concepts. Mathematics, out of which mathematics is must. The statistical knowledge is must. The statistical knowledge is must. Hmm? The applications of AI. See again, so I've been stressing on this word. Don't go with the wrong impression that these are only the applications. I've been mentioning some of the applications over here. See the business applications where financial decisions can take place, where the system should give. Suppose if I want to go for a loan, where the manual process should not need not take place, where a particular person will go through my what is this go through my documents and then say whether I'm eligible or not. All those days are gone. Now if I want to go for a loan, I feed in my data, immediately the system should tell whether I'm eligible or not, if I'm eligible, for what amount of loan I'm eligible, and how should I make the repayment. Based on the inputs I give, the system should give me a decision rather than a man involving a person, a human being involving it. Only the inputs have to be provided by the respective human being. The outcome should come from the other party. That's how financial decision should take place. The engineering, how to check the design, offer suggestions to create new products. See, n number of products are coming up. Your mobiles. Daily we see it, some new mobile with some new feature. Maybe 15, 20 years back. Yes, people used to use, I too used a mobile, but it didn't have any features. Only outgoing and incoming and an SMS. We used to send SMS. We used to get incoming calls. We used to get, we can make outgoing calls, and incoming and outgoing SMS, everything was charged. But today, everyone wants a smart mobile, which has got n number of features, multiple features, a rich set of features. So keep on coming out with new products. That's what where your intelligence comes into picture. So how should you attract the society? How should you do something to the society? See, a mobile is something relevant to the society. That's how you can map this art. Say, I don't know how many of you are in touch with this program outcomes. See, you have program outcome 6 as engineering society. See, you are an engineer, computer science engineer or IT engineer. How are you useful to the society? How do you map yourself to the society? Yes, I have come out with this product, or my services are useful to the society in this way. That's how you can map your engineering skills to this. Okay, manufacturing, the assembly should take place, and all this. See, most of the these concepts, the mechanical devices, the assembling would automatically take place. Where everything is readily made over there, the human intervention is made less. Medicine, see, this is one field which has taken a huge contribution of a huge usage of AI monitoring, diagnosing, prescribing. See, even the prescription also takes place by the machine. The education, yes. So in education, you may say that I give you an assignment. I ask you to submit the assignment. Now I should be in a position checking that whether there is any plagiarism over there. Hope you know what plagiarism is. What is plagiarism? Where, see, one student writes down the content, another student simply copies the same content over there. So it will be 1:69 there. Or two students come over there with some good concept for the assignment, good solution for the assignment. The remaining students, yes, that will be shared and they produce the same thing. Maybe I may not be in a position to identify whether the human being, it would be difficult to identify whether there is plagiarism or not. That means whether it is copied or not. If there is a tool, yes, I can, in the teaching, I can use it. I can use. See, and now I need not take your attendance. You will have certain some feature in Google Classroom which will automatically record the attendance. See, why am I taking the attendance? Your attendance will be cross-checked over there with the automatically taken attendance. Some students, see, due to some network issues, they might be missing. They say they might be leaving the classroom they might be leaving the classroom in between. So all those things can be automatically monitored. So that's also useful for education purpose. See the fraud detection. See the credit card fraud detection. See the financial frauds. This you have made. See, you have been frequently coming across. Yes, maybe 2 years back, my credit card was used in UK. I've never been to UK. I never made a transaction in dollars or other currency other than Indian currency, but it was already used for about 55,000 Indian rupees. That's what the fraud, financial fraud is. So you can have the fraud detection. You can use artificial intelligence in order to overcome that. See, this is object identification. Most of you might be seeing it. See, this is a picture. This is able to identify different objects over here. See, this is where, suppose if someone has not put on a helmet at the signal, the police people need not go over there, the traffic constable need not go over there and take a photo. Where you should see now that at most of the places the CC cameras have been installed. When they pick up this, it should be from that particular picture. It captures at that particular instance because it's continuous streaming. When you supply that to this model application of AI, what it should be able to identify is this person doesn't have a helmet, and you should pick up the number from that from the vehicle. And after picking up the number from the vehicle, a message should automatically go to it. Yes, this is the fine. You did not put on the helmet. This is the fine that will be levied. But now that's not happening. What's happening now? The police traffic constable comes near to you and takes a photo, and then that photos will be forwarded. No, it should be automatically taking place. Maybe in Western countries, this technology is there. When you do not put on your seatbelt in a car, yes, you get it. No one is going to stop you there. You get a message. Yes, this is a fine levied for this misconduct. You have to pay. There is no other uh, argument on that. That's how things should take place. See, the space shuttle scheduling, automated planning and scheduling of space shuttles. See, the space controlling is taking place right from the Earth, the ISRO, everything. So the information retrieval. See, when you see in your Google search engine, you type in some word, it will retrieve all relevant documents. Normally, the first 10 links are most relevant documents it's going to pick up. So you see when it is going to pick up, it has to intelligently pick up something that you are indeed looking for. It cannot simply throw some data for you where you start searching the data. So that's how it should take place. So there are certain other applications. This is just to give a small outlook on the the correlation or the linkage that's going to take place between deep learning, machine learning, and artificial. See, the total the outermost circle is artificial intelligence. Artificial intelligence, and and a domain of artificial, that means a subfield, a subdomain of artificial intelligence is machine learning. So in machine learning, you will have several algorithms, which see the combination of this will give you better results. And a subdomain of machine learning is the deep learning. Okay, always is this relationship is necessary, is important. See, the outermost domain, the main domain is artificial intelligence. In that, the key domain is machine learning, and that is the subdomain is machine learning. And so, machine learning is a subdomain of artificial intelligence, and deep learning is a subdomain of machine learning. So, a few more applications. The Google AI powered the predictions. See, one of a very good. You can search for this app, the Waze app. The Waze app. So it will clearly tell you what are the traffic incidents that are happening, what is the current situation of traffic, how should you move. So it is going to completely give you a picture of the transportation. This is application of AI in transportation. That is Google's AI. So you may look at your Uber. It clearly tells you when to go fast, when to not go. If you go in this direction, there will be heavy traffic. You will be delayed by 30 minutes. See, now when you book an Uber car, what happens? It says that yes, it's going to arrive to your place in 5 minutes. How does it say that? That's estimation of time. How is it taking place? That's what artificial intelligence is. It has to determine. Yes, if the driver is at so and so place based on the distance that has been calculated, it could be roadway distance or aerial distance. Normally aerial distance should not be taken into picture, it should be the roadway distance. Yes, based on the traffic that's present over there, it is going to accordingly consider all those like, parameters, and then say that by in 5 minutes it's going to arrive. See, this is what say the ride sharing. This is one more thing. The ride sharing apps like Uber, the Ola. It's the same see if 4 to 5 members are moving in the same direction, and see if I board the car at one place, another person board the car at another place, another person board the car at another place, and if we are going in the same direction, we can share the car. See, obviously, what happens? Our prices, the prices would be affordable, and at the same time, we can reduce the traffic also. Instead of going 4 persons going on 4 different cars, if all the 4 persons moving in the same direction can share the same car, obviously the traffic reduces, the utilization of fuel reduces, everything comes into picture. See how we can make effective usage of those systems, those services. See, this is just a heat map of Uber. What does this heat map tell you? See, normally drivers normally use this, Uber drivers or Ola drivers, they normally use this heat map. See, where there is exactly demand for the cars. And when there is a high demand for the cars in certain locations, the prices will be surged. The such prices take place. Now that if I look for a car, it could be 100 rupees. Maybe after few seconds, if I look for the car, it might go for 500 rupees. So that means there is heavy demand in that particular location at that particular distance of time. It also depends. It's dependent on time. So obviously, what happens? The prices do increase over there. So if this heat map clearly tells you, see, these are the colored areas. This clearly tells you at which place there is a demand for cars now. So accordingly, they'll be staying in that particular location, such that they get better say, of money for that. See, normally when it costs only 100, 200 rupees, when there is a high demand, what happens? The prices go up. In place of 200, if he gets 500 or 600 rupees, it's a good price. And definitely, if it is a demand, well, the customers go for it, the clients go for it. So that's what this heat map tells you. And see, normally, and most of you people who have availed the facilities of Ola and Uber, you might have noticed this surge prices. And how are the surge prices taking place means using this heat map. And the heat map is relevant to Uber. And this is not something a location of India. This is San Francisco. The commercial flights use is an autopilot, and this is something very old concept. Autopilot means, see, normally the role of a pilot would be for landing and for takeoff. The rest of the thing will be automatically done. That's what you mean by an autopilot. When once it takes off, gets into air, the total control will be done by their system over there. The key role over here while landing and while takeoff, where the pilot plays their role. See, this is again in transportation. See, when you reduce, as we said, sharing reduces the number of cars. The auto-driven cars, that means driverless cars, the number of accidents reduce because they will not be going too fast, they will not be going too slow, accordingly based on the situation, based on the environmental situation, based on the traffic over there, accordingly it maintains everything, and the number of accidents reduce, and efficient rates take place, and it reduces the number of cars on the road by up to 75%. See the effectiveness, the smart traffic lights, this is something very important. Today morning only, I've been speaking this to someone else. See, now that we have fixed time traffic signals, if I had, say, minimum on 30 seconds or 40 seconds, you should be waiting for a green signal to come from a transition of red signal to green signal. No, when there is no traffic over there, when there is less traffic in one of the directions, it should smartly take a decision. It should smartly take a decision. That's what you mean by smart traffic lights. Suppose if there is one heavy traffic in another direction, less traffic in another direction, so more time should be provided for the direction where there is huge traffic. The AI should play its role, and you people should be developing such kind of applications. That is the role of an IT or a CSC student. The applications of AI in email. See, automatically you'll have spam filters. How does it do? See, it says that Gmail successfully filters 99.9% of spam. See, it is automatically filtering rather than allowing them to your inbox. It's not allowing them to your inbox. Indeed, they are filtered by your Gmail server and they are placed in a different folder. They will not be put in your system. So automatically it does. That means it will have a set of rules out there. See, as we said, it will have a set of rules. If that it meets the set of rules, see, based on the situation out there, it could be spam or non-spam. Similarly, smart email categorization. In Gmail, you might have observed you'll have three or four different tabs. One is inbox, that's your personal. Other one is something relevant to promotions. Other one something relevant to some other concept, maybe something relevant to your social networking. You'll be finding different tabs. That's what smart categorization. Are you doing it? No, the system is automatically doing it based on if it is something relevant to social networking, it is moving into that particular tab. Something relevant to person that's moved in that particular tab. It is something relevant to promotions of business, it's moving to that particular tab. That's what smart categorization is. This is one which I've spoken earlier, the plagiarism checkers. The plagiarism checkers. You have, so there are several tools right in nowadays. It's available. I need not take the faculty or the person, human being need not take any pain. We supply this content to the plagiarism checker. The plagiarism checker will give us a report. This is the amount of plagiarism that's available based on the previous text. Suppose if I ask you, if I give you an assignment, even the first person or the second person who is taking up the assignment in the right sense might depend on some Google resources. So if you depend on this Google resources, what happens? If I send your document this is to this particular tool, that will tell you so where exactly you picked the content from. That's how we can determine the amount of plagiarism that has taken place in the document. The robo readers. The robo readers. See, when there are huge documents, and if grading, see something like the GRE, n number of good number of students, and they have to analyze everything. If it is human intervention, it takes hours, days of time. Let there be a system, an AI application, which does as this grading automatically. That's robo readers. This automotive industry, we are assembling everything, manufacturing the lathe, something very good and very much necessary for mechanical fields. And see, even though it is mechanical domain, our role is there. So we CSC or IT people play our role in every domain that's available. Without us, they are not there. They are totally depending on us. So there is heavy demand for us. See, if you are a very good AI engineer, okay, there is good demand for you in the market. And as my sincere suggestion to everyone is in this during this discussion, in this part of discussion, if you are good at Python, you can do wonders with the artificial intelligence. See the banking. See now that if you get a check, what exactly are you doing? You have to deposit the check in the counter in the bank. You have to physically go to the bank. Can't we do it from our mobile? That's what AI in banking. This is social networking where the facial recognition and most of you do have the Facebook account. I do not have, but most of you do have Facebook account. The face recognition automatically takes place. This is one thing I've been speaking about, the game playing, the tic-tac-toe game playing. See, when you place this, indeed, when you actually play it physically, we go with only 3 points with us. And we keep moving them. But here, how does it normally when it's tic-tac-toe? This is basic tic-tac, where we will have 9 grids, which will have 9 grids. This X is one person playing, this O is another person playing. And I hope most of you know this basic game, which you might have played at a early age. So either the 3 axes should be in horizontal direction or vertical direction or diagonally, then only it would be a winner. It would be a winner. The person who places that coins either horizontally or vertically or diagonally, that would be. Now, can you write down a program for this? So consider this as the first assignment for you. Write a Python program. Hope the Python is covered for you. Is Python covered? CRs?
Yes, sir.
So take this as a challenge for you. Try writing down a program where the human being plays with the computer for the tic tac game playing. Indeed, it's not part of our syllabus, but try doing it. That gives you a good experience. Write a program using which computer never loses. See, you should when you write down the program, you should always go with the perception that the computer should win the game when it plays against the human being. Don't go with the wrong sense. I'm developing it, so I have to win it. So you are developing the program for the computer to win in the maximum times. So these are these are these are different situations. You can take this into consideration. These are different situations. See, the first person has placed it over here, X. The second person has placed it over here. Next, the third, again, the first person has placed it over here because either it should be horizontal or vertical or diagonal. It's next. Since if see the second person does not place his coin over here, what happens? This person wins. So he places over here. Now, when this person does not place something over here, he will win. See, this is a situation where this person has not placed it over, indeed, he has placed it over here. And then the second person has placed the coin over here, and this will be the winner. Who won it? Not the X, the O has won it. This is just a scenario, just to explain the scenario where most of you are comfortable. How do you program it? There are different approaches. There are different approaches. So this is one approach. This is one approach. This is the typical layout for the grids. 1, 2, 3 sequentially numbered. So initially fill this with zeros. What does zero represent? Zero represents a blank position. Now, one person playing, and there will be two persons playing. The first indicating X. That was the first person who is playing it, he will place a X. The second person who is playing it will place a O. So this is one approach. How do you develop a program for this? That's so the first approach. What does it say is the first approach. What does it say is you consider all possible states. Suppose see this here few scenarios. If this is the first state, what could be the next state? See see, this is the initial state. All zeros means all 9 positions are zeros. The next state could be the first person could place someone or in the fifth position. Next, suppose if this is the current state, that means the first person has already. The second person could place somewhere in the second position, somewhere. So if you go this way, you have to go with the number of permutations and combinations. So see, the user can place this in three different in all available 9 blocks. So the number of possibilities would be say, either 0, 1, or 2 should be placed. In which position? See, it's 0 means empty position. X means occupied by the first person. O means occupied by second person. So what will be the number of possibilities? You have to go with the 3 power 9 possibilities. That means you should have 19,683 available positions over there. All this should be made available initially. See, this approach, if you can develop all these possible combinations, so if this is the current state, what could be the next state? If this is the current state, if you can determine all these 19,683 current states and the possible following state, and if you play a game, definitely the chance of winning for the computer is very good. See, it's a bit tedious, but this is one way of doing it. I'm not asking you to do this way. This is one way of doing it. See, if this is the current state, so all zeros. Look at this first scenario, all zeros. See, when you diagrammatically represent, this is the situation. And what is this next state? New board position. At the fifth position, I have a 1. See, at the fifth position, I have a 1. Here, 1 implies the first person playing, nothing more than that's nothing but X. If this is the current position, what's the next position? See, 1 in ninth position. See, in ninth position, we have that's the current position. In the upcoming one, you have 1 in ninth position and 2 in the second position. See, this will be the next one. So, this is only for understanding sake. If you can see, you have to develop all the necessary possibilities. And that necessary, developing all the necessary possibilities, we normally call it as the state space. Later we learn the state space, the complete space. From that particular space, you can pick up the solution based on the current situation. See, the entries of a move table are carefully designed manually. See, look at this in advance, keeping in mind that the computer should never lose. That means all this database has to be prepared. And this database is nothing but your knowledge base. So this will act as your lookup table. So when the human being gives this particular situation, is in this particular situation, what should be the situation for the computer? What should be the decision that should be taken by the computer? This will be the decision that will be taken by the computer. All the possible combinations should be initially fed into the system. So that we normally call, see here it is, he is calling it as a move table. We can normally call it as lookup table. So all possible board positions are stored in the current board position column, along with its corresponding next possible board position. Once the table is in, that's important. Once the table is designed, the computer program has to simply do the simple lookup. It will take the current position and then accordingly take the next position. So the algorithm for it, view the vector board as a ternary number. Hope you know what ternary number is. What is ternary number? Binary number means there'll be only 2 digits number system. Ternary number means there'll be 3 digits, 0, 1, 2. And in this particular one, you will be finding, say, in this particular matrix, you'll be finding only 3 different values. One is 0, representing the empty location. 2 means that's the place occupied by the second person. 1 means that's the place occupied by the first person. So that's the reason the algorithm says view the vector board as a ternary number. You should not have other values other than 0, 1, and 2. You get an index by converting this vector to its corresponding decimal number. Okay, if you convert the ternary number to decimal number, you will get the index of that particular box position and get the vector from new board position stored at that index. The vector thus selected represents the way the board will look after the move that after the move that should be made. That means, see, initially you are having the complete set of locations, all the key positions. Now this is the initial state. Based on the current position, you convert that current one into a decimal value, because in this you will have only 0, 1, 2. Convert that into a decimal value. Based on that position, identify the respective value from the lookup table and place it over there. Set the board position to that equal to that particular vector. So this is the first approach. This is the first approach. What's the advantage of this? This is efficient. Why? You will have a ready-made lookup table with you. The only thing is, yes, this is my current position. Look up the, find the respective position in the lookup table and pick up that value. And pick up that value. That's it. But there are several disadvantages. Look at this. Lot of memory requirement to store the move table. That's the lookup table. To specify entries in the move table manually, lot of effort is required. Creating move table is highly error prone because it's not a simple table. It does have 19,000 plus entries. And this is simply a 2-dimensional one. If you want to go for 3-dimensional one, you need to go for the 3 power 27 board positions, 3-dimensional. And moreover, this program is not intelligent because most of the work is being carried out by the human being. So this is one approach. This is one approach. This is another approach. This is another approach. See here, what does this say is 2 represents blank position. That means initially all the positions will be represented by 2. 3 represents the first person, the move made by the first person. 5 represents the move made by the second person. This is another approach. So you may come out with your own approach. You need not stick to these approaches. These are some of the approaches that have been already provided by the some of the programmers like you. So three sub procedures are used. The first sub procedure, that means the sub procedure means the function. So what does this function do? Using this function, the computer can make a move in a square n. So n is the value that will be provided. Accordingly, it's going to move to the respective position in the table. Next, make two. This is another function. This function helps the computer to make valid two move. Valid two means two. What does two imply? Two implies a blank position. That is valid two in any row, column, or diagonal. Next, this is another function. What does this function do? This is going to specify the possibility of winning. If a player can win in the next move, then it returns the index from 1 to 9 of the square. That constitutes a winning move. Otherwise, it returns a 0. So if there is a possibility of winning in the next move, it's going to give you one of these values between 1 and 9. Otherwise, it's going to return 0. So three procedures have been defined. Three functions have been defined. One is go, the second one is make, the other one is pos win. That is possibility of winning. If the possibility of win of p is 0, that p cannot win. See, if the value that is sent by that is 0, what does it imply? Definitely it should be a value from 1 to 9. If it is 0, it cannot win. Find whether the opponent can win. And how do you find whether the opponent can win? This is the way we find 3 into 3. That means two positions are already occupied by the first person. 3 means representing the position occupied by the first one. That means the first person has placed this, has reserved the particular spot. 3 into this. So if the third position is 2, what does 2 imply? Blank position. So if 3 into 2 is equal to 18, that X player can win as there is no blank, as there is one blank square in the row, column, or diagonal. If it is for the second one, see, the second person position is identified by 5. So 5 into 5 into 2, if it is equal to 5, then O player can win. That's the process that's being applied over there. Two approaches. And these are the moves. C plays X and H plays H means human being, and C means the computer, the system. So the first move, either use go 5 or go 1. Go 5, this could be anything, you can start with anything. Go 5, go 1. The third move, so you may ask, so what is the second move? I'll tell you. The third move, if B9 is blank, then go 9. That means call this function. Else make 2. That is called, and we are calling those sub functions go, make, and possibility of win. See, if it is 5 move, that is fifth move, then this procedure has to take place. If the moves are 7 and 9, then the maximum moves would be 9 moves only. If this is 7 and 9, this process should take place. See the second move. If B5 is blank, that means in the board, if the position is blank, then go 5, else go 1. Fourth move, sixth move, eighth move. So totally 9 moves. And every move has been perfectly defined over there. See, all these 1, 3, 5, 7, and 9, all these odd moves have been given over here. And all the even moves have been given over here, 2, 4, 6, 8. So these are the 9 different rules. These are the 9 moves, means 9 different rules. How to make the next move? How to make the next move? From the current move, what should you do? That means 9 different steps, you may call them as 9 different rules, you can call them as. Accordingly, the next position has to take place. The next move has to take place. So this is one more procedure. And the advantages, see, you're not generating all, see, as in the previous approach, where we need to develop a huge table, that's not necessary over here. So this is memory efficient. Easier to understand as complete strategy has been determined in the beginning. So what's the strategy over here? If 3 into 3 into 2 is equal to 18, then X player has the chance to win. If 5 into 5 into 2 is equal to 15, then the O player has the chance to win. That's a simple strategy, winning strategy. And what are the moves? All these have been predefined. All the 9 rules have been predefined. See, all these are odd moves. And all these are even moves. So all the 9 different moves have been predefined. So the control, the strategy has been given in advance. And What is the disadvantage? Not as efficient as the first one with respect to time, because in the first one everything is predetermined. That means the total lookup table is there. So quick access can take place. Whereas that might not take place in this particular second approach. Because see, there are 9 different rules, and these at times there could be a chance to, there could be a position where you need to go through these 9 rules in order to come to a particular decision, and this is not viable for the 3D game. Only for 2 dimensional, that's good. So I'll stop it over here. I'll stop it over here. And there is one more approach. I'll discuss this in the next class. I'll discuss this in the next class. And possibly in the next class, I'll put an end to the first part of Unit 1. And if time permits, I'll go to the second part of Unit 1 also. Okay? Any queries? Anyhow, I'll post this presentation once the session is up. Any queries? I do have 53 students. CR, can I have the attendance number? See, those are the roll numbers who are absent. If you need any clarification, please ask the CRs, because that's the attendance. I'll be verifying this attendance with the auto-generated attendance at later, maybe after the session is over. Thank you, and if you do not have any doubts, thank you, and you may join the following session. Meet you on Tuesday again. Yes, people, you may leave. It looks like you have the HOD ma'am's class following this.